So this is going to be a bit of an unconventional video today. I'm going to talk about the tech stack that we're using to build Dev in a Box and some of the unconventional decisions we've made that I think have made it a better product. And the most unconventional of all those decisions has been our decision to use SQLite in production. Now, if you're not in the know, typically SQLite isn't used in a distributed system like ours. It's basically more meant for on-device or local storage, right? It's a really good database system. It's used by the Library of Congress to store all of their data and process it, but it's not typically something you would see in a distributed system. And I think that there's actually a lot of value in exploring the ability to use a technology like SQLite to do things you wouldn't normally be able to do in a production system. So why did we choose SQLite? It's a bit of a story. But basically, we had about 4 major goals for our infrastructure. I had some incredibly stringent privacy and security things I wanted to do. The first of the guarantees I wanted to have an extreme level of tenant isolation. I wanted our system to be the sort of system where tenants can't ever possibly, it would be physically impossible to access another person's data. I didn't want to be the same way that there's a lot of services out there that are handling people's code that have had these major tenant breaches where because all of the customer's data is in the same database, when they get hit, a ton of code and a ton of intellectual property and stuff just gets leaked out into the public domain. What I wanted was a system where basically every customer's project has its own database and its own level of security and its own encryption and a very, very intense handshake required to access that system. And this leads into like something that we haven't done yet, but as a future plan, where I want users to be able to generate an identity key that they use to encrypt their database. And we would never see the identity key. But basically would let them unlock their database, but have this guarantee that us as the service provider could never peek in and have a look, which is fantastic for privacy, but it's also fantastic for security because it means if us as the service provider get hacked, we can't decrypt the database without the key from the user, which means that the hacker has just basically got useless data. Now, the other 2 guarantees are a lot less interesting, right? It's basically that we wanted the service to be low cost, we wanted it to be affordable for us to run, and we wanted it to be really, really fast. I wanted this to be an app that felt fantastic to use. When I was looking at like a database technology to build this upon, I couldn't find anything. And for a very short period of time, I actually considered building my own database technology, which everyone knows is batshit insane and is a very vain thing to think. But I did realize when I was doing that analysis that I could take SQLite, which is one of the most reliable pieces of software on the planet. It's had 26 years of functioning really well, and it makes some great guarantees about data. And I could take that and basically build a distributed system on top and a extended piece of technology layer on top of it that allowed me to do all of these security guarantees, but still know that my database technology was rock solid and I wouldn't have any problems. And SQLite has let us achieve all of the goals that I set out to do. And this is how. And I think before I can get into this is how, I do have to talk about the elephant in the room, right? Which is the write limit constraint. So the reason and the big problem with using SQLite is essentially it only has one writer. So you can't parallel your writes like you can in other databases, right? You have to basically plan ahead and be very intentional because unless you do this, basically parallel writes can get in the way of each other and you can lock your database and it's a terrible experience for the users. It means that the response time is really slow and it can even, cause problems where if you don't do it right, it can crash your server and do the sorts of horrific things that keep system administrators up at night. So with SQLite, you become responsible for the complexity of handling this writer. It's not abstracted away like in other services. But I actually think this is less of an issue practically less of an issue than people give it credit. We've had an incredible amount of innovation in the actual hardware that we're using. And the current drives we've got are incredible. It's trivial to get about 5,000 writes per second in an optimized write-ahead log, which is way more than most apps could ever dream of. But with SQLite, if you think about how you use it effectively, you can actually batch your writes and basically you can write really intelligent queries and really intelligent requests to the database to make sure that it's using this single batch writer effectively. And you can get about 180,000 writes per second out of it, which I benchmark and I think is just more than enough for a startup like ours, especially with an extreme level of tenant isolation where we actually have a database for each customer, which means that the write ahead log and everything is distributed across many databases. So we're already reducing the congestion on that constraint. Of course, this means you have to take a lot more responsibility. You're taking a lot more responsibility, but this is giving a lot more control. I mean, I've been able to do things that I think are really quite complicated in a very simple way because of this architecture. I mean, the greatest example, I think, is the handshake mechanism. In any other service, it'd be very complicated to build the levels of abstraction needed to basically say that, hey, this database is 100% secure from anyone trying to access it outside of people that already exist within the project and have already been given permission by the administrator. Very, very hard. The other great thing that I think has made life so much simpler is that SQLite has an incredible ecosystem built around it. One of the greatest examples I have of that is that we needed a vector database for Dev in a Box, right? There's Postgres implementations and all that sort of stuff. But a lot of the standard way of doing it, and the way I've done it in other applications I've worked on, is you have a separate vector database, which adds round trip time and all sorts of stuff. With SQLite, I can just have an extension that gives me an SQLite database with a vector database inside of it, which means that all of the complexity that I'm building around about distributing it and making sure it's secure and that can apply to my vector database for free. I get a free lunch on that regard, which, for me, really, really great. Really, really simplifies everything that I'm doing. And like I said, we are using batching heavily. And the reason we have to use batching heavily is because our application is actually quite write dense. We have an indexing process which basically takes raw source code and generates a ton of different layers and abstractions and artifacts that we use to bootstrap up to creating a high level, I like to say, a Google map of the software. It's like a high level understanding that we can then give to a large language model to trace through and find all of the defects and the vulnerabilities. But that process does, thousands of writes per second. And because of batching, we've been able to have that have minuscule effect on the CPU and also minuscule effect on the users. There's no locking, there's no nothing. It runs smoothly, and it's pretty cool. Now, the basis of all that, of course, is that we are sharding the databases. We are taking the single writer constraint, and by creating more projects, you can split that writer across all of the different projects, which, reduces the congestion, and is another way to think about this stuff, that, you can get creative with how you design the system. And if you design it well, you can work around these constraints, and these constraints can give you a lot of power. So SQLite really is giving us everything we need. We have an extreme level of tenant isolation. In order for someone to join a project in our application, a write has to be done inside the project database. The global database can't just add someone to the project. Someone can modify the global database to say, hey, I'm a member of this project. But unless the project has the matching key, which required the write to be done on the project's machine, there's no handshake, and it just kicks them off. It's very different to other services where if you're using Postgres, there's a lot of abstractions you have to build on top to basically ensure that there is no tenant breach. And you're not dealing with this risk anymore of a single line of code being wrong, meaning that people can jump from one tenant to another tenant really easily. To bring it back to simplicity, right? I just have to manage this in a single file that manages this handshake. And because of this handshake, I know it's impossible for anyone to query outside of that and gain access to anyone else's data, which is just fantastic as a basis to build upon for ensuring privacy and security. Now, cost is another thing which is actually ridiculously easy because it's just a file on a disk. Disk space and volume storage is really cheap. You're not paying the markup that you have to pay with other providers because you're managing all this yourself. Another fantastic thing is that Lightstream, which is another massive part of the ecosystem, lets you back up in real time to an S3 bucket your database, which means that you can actually have fantastic reliability guarantees around backups that mean that you're not going to have any data loss while doing this. The last thing is speed, really. And speed is, again, even simpler for us to do. In a traditional web app, you have your server, and then you have to call out to your database server or your vector database server. And there's a round trip time, and you pay the tax of having to do that round trip time, because you might also have the fact that your server and your database server could be in two totally different locations. With SQLite, essentially because the file exists on the disk of the server, you just have to ping to the server. And we're running Rust on the server, so the response time is really rapidly fast. I mean, I've had 30 millisecond response times from our production server, which, obviously, there's a bit of luck involved in that. But that's really cool. It's really fast. It means that everything feels snappy and smooth for users when they're using this system. And one of the cool things we've got as well is that we actually let people select servers for their projects that are closer to their location, which is just another way for us to bring everything closer to the user and give them a little bit more control over their data and their privacy. So the final piece of this, of course, is the future plans. This whole idea of letting people encrypt their database, of letting people have total control. And we're using another extension here to do this, right? It's SQLite Cypher, which basically the way that works is it's a just-in-time reader. So instead of decrypting the entire database to read it, what we do is we use SQLite Cipher, which has the encryption key stored in memory, and basically it can pull out the pages and decrypt them as the user makes requests. That database, which is sitting on the server, is never fully decrypted, which means that an attacker or even us can't just go into the file and unencrypt it. It's basically useless data. Of course, to be realistic, right? The decryption key is still sitting in memory, but I think that it's a much, much, much higher level of security and privacy than other services can offer. And the only reason why this is an end-to-end encryption is, of course, because of all the intellectual property that goes into a system like this. I mean, I think our system is one of the best tools for finding security, for finding bugs, and for identifying optimizations. And we do need, to have access to your code to do that. But hey, if your code can be encrypted by you at rest so that, hey, you actually have to be using the service for it to be unlocked, I think that is an incredibly higher standard of security and privacy. And I think that's the sort of thing that every service should be doing. And I'm very proud to say that this is the direction that we're heading in. So that's basically why we chose to use it. That's why it's working so well. I'm very excited about the future. I've got some really cool videos planned on this zero knowledge system, where we're actually going to show us debugging it and figuring out any security flaws in it, and then optimizing it, and then also stabilizing it with our tool, and showing you how you can take a piece of software and make it really high quality. Now, of course, we weren't able to do this with the core application because, when you're building it, you do want to keep stuff close to your chest, and you do want to basically make sure that you iron out all the bugs. But I think that now we're building newer systems and we're building on top of the base layer and everything's really solid, we can start to share more of that. So I'm really excited about the future of stuff we're doing on this channel. So I hope that if you're interested in technology, if you're interested in how we make software quality, that you'll subscribe and follow us along in this journey. So thanks so much for watching the video. Have a lovely day, and I hope to see you again soon.